Let's move on and go to our UCS manager, because that's where we start configuring our iSCSI boot. So in my case, I do not have any servers profiles configured yet. This is an empty configuration, so we will start doing some configuration here. Now, the only thing I cannot do is I cannot do the exact same thing as I could do with Fiber Channel boot. So Fiber Channel boot, I can prepare that 100% before I go into the server and apply it. For iSCSI, there are things that I need to configure separately per server, like the IQN, like the IP address. So we will see how that goes here. First of all, I can create a policy for iSCSI authentication. So the fields that I have in that policy are just what is the username, what is the password that I want to configure it with. We're not going to be bothered with that right now. What we are going to be bothered with is pools. Because iSCSI there are two pools that I need to configure. I need to configure an IQN pool, remember, because my server needs to have an IQN. And my server needs to have an IP address. Now Cisco chose to separate those two together because they say an IQN is more of a SAN-based approach, more of a SAN-based feature, whereas the IP address is more of a LAN-based feature. So my iSCSI initiator IP pool is right here, is here in the LAN section. Now, what did we say about the pools or the IP blocks that we are using? We are using 198.1.100.0/24. That is the IP block that I'm using here. So that is also the IP block that I need to give to my servers, because I will set my servers into VLAN 100 and because my servers are in VLAN 100, they can access the iSCSI storage array. Excuse me. So this IP block, this IP block is starting at 198.18.100. Let's start at 50. We'll configure a size of 4 because I only have 4 blades. We might have 2 VNICs, so let's make 16. Just some sort of a block. It is a /24. I can specify a default gateway, but technically I do not need them because it's just within the same subnet, so I do not need a default gateway to get out. I can even use DNS to specify the iSCSI host, so I do not need to configure that based on IP address. That is a best practice, of course, because one lookup less in the network is always better than doing an additional DNS lookup. So I would configure that on an IP basis and not on a DNS name basis, but you can do that. So this is everything I need to do here in my block. So these addresses will be assigned to the iSCSI NICs later on when we start applying them. Next, our IQN pool. Here I have my IQN pool and I say create a new pool. I'm going to call this RIC IQN. What is the prefix? Now my prefix is always IQN, and then behind that I'm going to say 2013-1130 dot, or this. And I might need to change that because Cisco is using a little bit different format for IQNs, but we'll see what kind of IQNs will be assigned here. So I'm going to say the prefix is IQN.2013-1130, just like we configured that on the MDS. Next we get asked for what is the suffix. The suffix was, what did we say? IQN.2013-1130.blade and then a number. So in my case, I'm just going to configure blade. I'm just going to specify here blade from starting at 1, and I say I want to have a pool of 4. Finish. Now I can check what is my exact IQN here. So IQN suffixes, I don't see that here. Now it's not going to show me the full thing. But what it will do is it will take the prefix here, place a dot in between, and then do the suffix. So you see I made a mistake in defining my IQNs used on the MDS, because UCS always adds this semicolon. So my true IQN will be IQN.2013.1130.blade and then :1. This is going to be my IQN, so I need to redo my configuration on the MDS to make this change happen. So sorry for that. Yeah, that's going to be it. So I'm going to redo some configuration on the MDS for that. First of all, I'm going to reconfigure my iSCSI virtual target, or initiator, sorry. So this iSCSI initiator is no longer existing, but this guy is 2013.1130.blade: 1. It's going to have these worldwide names. I can just manually configure them, right? Oh, that fails. So my initiator is correctly configured now. I need to edit my virtual target. Where instead I need to add the new initiator, which is this one. I'm going to say permit. And I need to update my zoning. Because I have a new PWWN, so no, actually let me delete the zones first. So no zone name iSCSI Z1 and no zone name iSCSI Z2. And I'm going to recreate it because I created a new virtual target or a new target. I also created new worldwide names because I need to reallocate them out of the pool. I cannot reallocate them, I need to create new ones. VSAM 500, no zone name iSCSI Z2. So, new zones. Zone name iSCSI Zone 1. I need to have some worldwide names here. So where is my iSCSI configuration? Right here. So the first member is going to be the server worldwide name. Second, it's going to be the virtual target worldwide name. The second one, as I said, I'm going to use the symbolic node name or the IQN of the blade. Of the blade, not the disk. And we're going to specify the worldwide name of the disk. What are my active zones? I have now the correct symbolic node name advertised here, and I'm using the new port worldwide name that I just created. So sorry for this, but I had to redo some of my configuration because the UCS doesn't support a free format of IQNs. I need to really stick to the allocation of how the pools allocate IQNs. So I created my IQN pool. I created 4 of them. Actually, I'm going to delete 3 again because I need to make sure that I'm only doing 1. Why? Because UCS will start allocating from pools from the bottom up. Meaning blade number 4 will be the first IQN that's going to get assigned. And now I'm just going to suffix blade from 1 size 1. Right, so I only have one IQN suffix. I will only roll out the template once on the service profile as a service profile, so I have enough with only one IQN. Right, so that is all the pooling and policing that I can do for iSCSI, because now I just need to set the remainder of all the settings in the service profile itself. So usually it's a best practice to have different network cards just for the iSCSI boot. So when we start looking at our server again, so how do we configure UCS? We configure the IQN pool. We configure an IP pool that we can use to give our NICs an IP address. And then all the other settings are done in the service profile, either the template or the direct service profile itself. And here in that service profile template, I'm going to set the IQN to boot from, so I cannot do that in my boot policy. And I need to set networking cards, meaning which NICs do I put that IP address on. So usually in our blade, we will advertise a number of NICs to our host operating system, remember? So we advertise the path A and the path B, just for data for B. And second, it doesn't have to be a new NIC, but it is recommended to have separate VNICs for iSCSI booting. Again, no requirement, but it is a strict recommendation. So iSCSI. So what I usually do with this is create another VNIC template. So I can configure my VNIC based on a template and immediately have the right VLAN assigned to it. Because on the data path, I have a lot of VLANs, and on the iSCSI path, I can dedicate exactly which VLAN do I want to give access to. So let me create a special VNIC template where the only traffic I'm going to allow from is iSCSI traffic. So VNIC templates, I'm going to say, let me make this a bit bigger. I'm going to call this iSCSI template. I'm going to run it across fabric A. It's going to be an adapter. Oh, and I did not configure the VLAN yet. And I still need to configure an uplink. Maybe let's do that first. Let's create an uplink. Otherwise, I cannot work with iSCSI boot, right? I first need to have a network uplink before I can do some iSCSI booting. So in our case, we go to Fabric Interconnect A, because again, I connect to switch 2, and Fabric Interconnect A is connected to switch 2. So if we go back to our drawing, sorry, this one. This is my drawing for the network. So what we have is we have our Fabric Interconnect A. That is also connected to switch 2. Remember, our nexus here will configure a port channel 1. This is going to be on port 9 and 10, and this is going to be on port 9 and 10 as well. I'm going to create VLAN 100 on the Fabric Interconnect, and behind here I will have my blade, and my blade will have a VNIC for VLAN 100, just to run iSCSI. So I'm going to focus on the creation of this uplink between the Fabric Interconnect and the Nexus 5K. So let's first do the UCS. So I'm going to say my ports 9 and ports 10 are going to be my uplink ports. Configure as uplinks. Yes, I do want to do that. Then next, go to the LAN part. Take these two separate Ethernet ports and create a port channel out of them. Ports 9 and 10. Finish. Do not forget to enable the port channel, otherwise it will stay in a disabled state. So that's all good. Now the switch part. We can configure the port channel, so we just focus on ports 9 and 10. There is something active here. I'm gonna remove that. All right. There we go. 9 and 10 are going to be in channel group 1, mode active. On port channel 1, I'm going to allow, switch port mode is trunk, and I'm going to allow VLAN 100. So this is going to be a tagged interface, right? Do not forget to put the spanning tree port type, edge trunk here. So my port channel 1 is going to be a tagged interface inside VLAN 100. So going back to our drawing, as I said here, this is going to be untagged traffic. So the purple line, this traffic for VLAN 100 is going to be untagged. Because I configured an access port for VLAN 100 here on switch 2. Then here, my VLAN 100 traffic will get a tag. Because from the fabric interconnect up to my uplink switches, I usually tag all my traffic. Is it up and running already? Yes, it is up. Perfect. Show port channel 1 participating. So we have an active link now between the Nexus 5K and the UCS. Running with VLAN 100. So show spanning tree VLAN 100. We see that it is allowed on Ethernet 1/11, which is our NDS. And it is allowed on port channel 1, which is the UCS server. So we have a forwarding path that Ethernet 1/7 is a link to the other switch. We don't really care about that right now. We just care about port channel 1 and Ethernet 1/11. So all good. Going back to our UCS. We have a port channel up and running. And we now need to configure VLAN 100, which is called iSCSI in my case. Doesn't really care, but let's configure VLAN 100 and call it iSCSI, which we have now. That VLAN is going to be automatically allowed on this link going up to the network. As we talked about last time about all kinds of things related to disjoint layer 2, we're going to automatically allow the VLAN on the uplink. Now, very specifically, I could map my iSCSI traffic to the fiber channel queue, where we talked about earlier, in one of the earlier questions today, we talked about the no drop queue, using that no drop queue for QoS or for iSCSI traffic. I'm going to show you how to do that. So here in the UCS system, I can check here in the packet drop column, I can check if I want to allow packet drops in a certain queue. Now, because I'm not using fiber channel over Ethernet traffic right now, but just iSCSI traffic towards the blade, I can use the fiber channel queue, which is unused right now, because usually only FCOE traffic is transported there. So now the queue is unused, and I can start using this for my iSCSI traffic. What do I need to run certain traffic in a no drop queue? Or in any other queue than the default? I need a QoS policy. So in this QoS policy, I will say this is going to be my iSCSI policy. And that means that I will place all that traffic in the FC queue. And here I map all the traffic received on a NIC that has this QoS policy set. All that traffic is going to be mapped into the FC queue and therefore will not be dropped. So there we go. And now we create our vNIC template. So let me get out of the way for that. Add a new VNIC template. It's going to be my iSCSI template. It's going to run across Fabric A because that's where the only uplink is configured right now. Well, let's call it an updating template. And I'm going to allow the iSCSI VLAN. Now, do I want to have this tagged or not? If I run this configuration with only 2 VNICs to merge my blades, so if I'm using a Menlo card for this, I only have 2 NICs. So 1 NIC for Fabric A, 1 for Fabric B, where all my production VLANs are also running across. Then this would need to be tagged, of course. And I will show you how you solve the tagging later. So this is going to assume that on this VNIC, traffic marked with VLAN 100 will be sent and then forwarded. It will not set the tag of 100, it will expect a tag of 100. Now, because I'm using a dedicated VNIC just for the booting, I want to do that dedicated. I'm going to check the box for native VLAN. And why? Now I expect from the server, from the iSCSI boot driver, I expect untagged traffic. I can do both. I can set tags in the iSCSI boot driver, or I can just send untagged traffic and let the NIC itself solve the tagging for it. So in this case, this is my native VLAN. So the iSCSI VLAN is the native VLAN. So therefore I expect untagged traffic coming from the iSCSI boot driver. I'm going to set a MAC pool. I'm going to set my specific iSCSI QoS policy. And that's going to be done. Now I do need to fill my MAC pool with some MAC addresses, otherwise this will not work. There we go. So we created a VNIC that we're going to use for our iSCSI traffic. So we created an uplink, we created the VLAN, we created IP pools and IQN pools, and we created a VNIC template. So now we can start combining everything together in the service profile template. Templates are created, pools are created, so what remains is creating a service profile template. I'm going to create a template because I want to show you what I can and cannot do. So SP template, create an updating template, use a hardware UUID, I don't really care. Now, storage. First of all, I'm going to ignore my local disk, so I'm going to set them to any configuration. And then for SAN, well, I do not want any VHBAs in my system. So I do not configure a fiber channel network to my server. I don't really care about that, so no VHBAs. I do care about networking. So I want to set that up for an export use, and I'm going to say, all right, this is my VNIC A. I'm going to allow this to Fabric A, allowing all the VLANs, do some stuff. Perfect. Same for VNIC B. That's going to run on Fabric B. Allow all your production VLANs. Use a MAC address, MAC default. All right, the same thing here. Use this MAC address. Then I add my special iSCSI VNIC. I'm going to use a template for that. Oops, select that. Select the iSCSI template, meaning now I will start expecting untagged frames coming into the iSCSI VLAN. So VNIC A and VNIC B, those are just there to transport my data packets towards the network, and my iSCSI frame is there to connect to the iSCSI network. Now there is another special VNIC that I need to create. And this is actually not a VNIC because it's not a network card, but this is your iSCSI boot configuration that you're going to configure here. These are called so-called overlay VNICs. So a special iSCSI VNIC, just like on the MDS, we have our physical interface, that is the VNIC, and we have an overlay interface, which is the iSCSI interface. I have the same thing here. So on the physical VNIC, I set the VLAN stuff, I set the MAC addresses, just the hardware-based stuff. And on the iSCSI VNIC, so my overlay on top of that, sets the IP address and sets the MAC address for that, and sets special things just for the iSCSI communication. So if we start configuring that, I select which VNIC I use for the hardware settings. So this is my special iSCSI boot VNIC. This is not a boot policy. This is just setting an iSCSI boot VNIC, and this VNIC will allow the setting of IP addresses and all kinds of other things. So I can use even a different MAC address for this iSCSI VNIC, but I usually don't care about that. I'm gonna just assume the MAC address of the actual VNIC going outside. So the virtual NIC, the virtual VNIC in this case, it's not going to have a separate MAC address. I don't really care about that. And here I can say, do I want to use the native VLAN here? So it automatically marks it as native. Or do I want, so what I select here in this VLAN drop-down box are all the VLANs that are allowed on this overlay VNIC. So that's what I configure in my VNIC template. All the VLANs allowed there, I can select one of them here that I'm going to use to transport the iSCSI frames in. In my case, the iSCSI VLAN, and that's going to have no VLAN tagging on there. So again, this VNIC is especially created just for the boot policy, so that iSCSI VNIC here, I can just reuse that for normal data traffic. This iSCSI VNIC here, this special iSCSI VNIC, this I can only use this one during the boot of the system. So this is that special interface that will get the IP address assigned and will start doing its magic. I'm going to create one, but the real magic is going to happen during the boot policy configuration. I'm going to go next. In which order do I want my VNICs in? I don't really care here. I usually place the iSCSI VNICs lower in the order because I usually do not use these NICs anymore when the OS is booted up. If I use, of course, my normal data VNICs for this, I do care. But for iSCSI, this is only used during the boot of the system. So placement, I'm fine with that. Now the boot policy. Let's create a boot policy. And the fun part is, if I create a separate boot policy, so this is just creating a boot policy like I would do in my normal tree view here. If I configure iSCSI boot, the only thing that I can specify is the iSCSI VNIC name. And that's it. So beside for selecting an iSCSI boot policy, iSCSI boot policies are useless because I cannot set the parameters. The only thing I can configure here is the iSCSI VNIC name. And that iSCSI VNIC name is that special configuration here, which I call iSCSI underscore boot. So what is a common practice is create a specific boot policy, like stated here, then add my iSCSI VNIC. Because if I would select a boot policy, let's create one. So let's create this policy and say iSCSI boot is called iSCSI underscore boot. I'm going to call it iSCSI. So I select the iSCSI boot policy. Now it only selected the correct VNIC. After that VNIC setting, I can change the iSCSI boot setting. And here I can set the parameters. So technically it's not very useless, but usually when you select the policy, you do not need to change anything about it anymore. For iSCSI boot, when I select the policy, I still get options to change the policy. Meaning my iSCSI boot is configured, or iSCSI boot VNIC, iSCSI underscore boot. And here I can say, all right, I'm using that iSCSI underscore boot nick. And I'm going to set some parameters. And where are they? For some reason, my button doesn't work. Create a specific boot policy. So for some reason, my UCS manager is not very cooperative. iSCSI boot. Go next, maybe go back. All right, that's strange. So let me set the parameters later, because for some reason the Java tool does not allow me to open up these windows anymore. I need to set some parameters for iSCSI, of course, but for now I'm gonna go next. So I only configured my iSCSI vNIC to be booted from. And I'm pretty much done right now. So going into my service profile template, I go into my boot order, boot parameters, and now I can set some parameters. So this is what I need to set here. I specify the iSCSI vNIC name, and now I can set what do I need to boot from. So do I need to authenticate anything? No, I don't. Do I want to set an IQN? Yes, I want to do that. Now it's going to fill in the name right here because, well, it can't right now because it's not assigned to a blade yet. And then finally, what is going to be the IP address? That's going to come from the pool. So coming from the iSCSI initiator IP pool, I'm going to assign certain IP addresses. And initiator names, going to use the IQN pool. So this is where my configuration comes together again. Now, I will configure a static target. There is also some such thing as iSCSI auto target, and the MDS doesn't support that. That's a special feature in iSCSI that as soon as it gets so I will do, this is a DHCP feature, but in this case, I'm going to configure a static target because my MDS doesn't support that. So what is the target called? Remember, this is the IQN. So what is our IQN? That's this, boot disk 1. Set that in there. What is the TCP port used? 3260. Do I want to mutually authenticate it? So do I want to do a two-way authentication? No, I don't care about authentication. What is my IP address? As stated here, that's going to be 198.18.100.10 because that .10 is the IP address that we configured on the gigabit Ethernet interface of the MDS. I'm going to paste that in here. What is the LUN ID? It's going to be 0 because I configured that in my virtual target configuration. So these are exactly the settings that I prepared, and this is going to be the target that I'm going to use to start booting from. Perfect. So what remains here is that I have an event here. What's it called? All right, don't care. So what I'm going to do now is I'm going to roll out this service profile template towards a server. So I'm going to say create a service profile called CCI DC. Just one. Perfect. And that CCI DC profile will be assigned to a server. So how does that look for my networking part? I have some MAC addresses assigned. And how does it look for the boot order? iSCSI boot parameters. My IQN is being assigned, but for some reason the IP address is set to pooled, is set to DHCP. I'll check that later. My target is there, and I chose the exact correct IQN, and I made another mistake because the initiator name between the suffix and the prefix is also a colon. All right. So this is the true IQN. So this is the true IQN. As you see here, IQN 2013-1130, blade, 1. And this is very limited how I can change that, because those colons, I did not choose them. Usually they are dots, but the UCS uses colons. So in my case, that means that I need to go back to my MDS and change some things again. Sorry for that. IQN 2013-1130, blade, 1. That's going to be my IQN. Statically assign some worldwide names. And I'm going to allow this in vSAN 500. Go back to my virtual target. Now my initiator this IQN is permitted instead of the others. And finally, I need to change my zoning configuration back. So sure run vSAN 500. I go into my zone set database. And recreate them again. So the PWWN that is assigned, I need to check that is assigned to my initiator. It's this one of the blade. And for the disk, it's going to be the one with 4C. On my second zone, I'm going to match on the IQN, which is this one. And the second one is going to match on the disk PWN again. Activated, show zone set active for vSAN 500. 2 zones active, new PWWNs and a new symbolic name. So now I know for sure that this is going to be the IQN that the server is going to log into. It's going to use. So let me first finish this configuration. I'll come back and I will explain all the steps one more time. So this is set correctly. Let me check if it assigned an IP address from the initiator pool. It should. No, it didn't. So you will see that the iSCSI boot parameters are not really bug-free. So in this case, you saw that I chose my IP initiator pool in the boot parameters, but here you can see that it is using DHCP again. So for some reason, the profile template did not push its settings correctly. Because, oh, here it says DHCP as well. Pool, okay. Now it is set to pool. Or not. Yeah, now it is set to pooled. Now let's check my real service profile because it is an updating template. Yeah, now it is set to pool. So For some reason, it didn't take the change in one time. So I had to change the service profile template again, setting it to a pooled IP approach. And that, because it is an updating template, it automatically pushed the change in that setting towards my service profile. So now I chose an IP address from the pool that I configured, from that VLAN. I chose an IQN, so now I'm ready to start rolling this out to a server. So let's roll this out to a server, saying server 1. All right, yes. QoS policy cannot be applied. Oh, yes. I forgot about that. I cannot use the fiber channel queue for anything else that is non-fiber channel. So I can create a fiber channel QoS policy, allocating traffic towards my fiber channel queue, but I cannot assign that. I cannot set vNICs, so Ethernet NICs, into that queue. It has to be fiber channel queue. It has to be a fiber channel interface or an HBA that I put into my FCOE queue. So I'm going to change this to the Platinum queue, because by default the Platinum queue also has the no drop statement configured. As you can see here, the packet drops checkbox is off, just like it is off for fiber channel traffic. So therefore also in the Platinum queue I'm not going to drop traffic. So that is all configured, and now I should be able to set the association. Associate the service profile with an existing server, server 1. I'm going to say OK. It's going to require a reboot. That is OK. So now it is setting up all its things. Oh, I first need to set some management IP pool settings, of course. Again, this is an empty configuration. Size is 8. Now it has an IP address, so now I can start my KVM console. So now my CIMC on the blade has an IP address. So now I can start running that. All right, there we go. So it's booting the server, and it will start setting all the settings using the GNU OS. So this will take a few minutes, and during those few minutes we will check the Cisco website for iSCSI booting on UCS, because there the commands are laid out for us. So if we go into the cisco.com website, we say, okay, we go into support, all products, unified computing. This is going to be UCS manager related. And I think it is at the white paper section, but I'm not sure. So there is a special iSCSI boot document. It's not here. Going into the GUI configuration guide and server configuration, I think. Server boot. Here we have iSCSI boot. So it's just in a normal UCS GUI configuration guide. So in the iSCSI boot configuration guide, what I see is that I have a command somewhere. So it will tell you exactly how it works, of course. But what I'm looking for is the troubleshooting command. And that might be in the CLI configuration guide. Yeah, it is in the CLI configuration guide. Verifying iSCSI boot. This is the one. No, that's also not the one. Where did I put that away? Right, it's a configuration example. That is it. That's what I was looking for. So there is a very good configuration example, and that should be in here somewhere as well. Go to configure. Let's go UCS manager. There is a section called configuration examples. So it's always looking for where the stuff is located. But here we have in the UCS manager section, on the configuration examples section, all the way to the bottom, you have the iSCSI boot configuration example. And why I want to go into this, that is because I have these special commands. So here I see exactly how I connect to the adapter, what command I need to specify, and now I can say that login command. And this iSCSI get config command will run some tests. So it will run a ping, for example, and it will start trying a login. So according to these messages, I can see what the current status is of the iSCSI configuration. So this is a very useful one. These are three relatively simple commands to remember, but if you forgot them, this is the place where you will find them, in the configuration example section. So we see that we cannot boot right now. So we already did some booting, but I first want to go into the CLI and check if everything is configured properly. So if we want to trust the server, we ran through a successful boot process, but we didn't find a device yet that has an OS installed. So let's check on the CLI. All right. So let's go back to our guide. It said connect to the adapter. So we first need to know, of course, what is the adapter that we're connecting to. The CLI will help you with that. So it will tell you it's the chassis, then the server, and then the ID of the adapter. Now we are running half-width blades, so we only have one adapter per server. So it's always the /1. If I have multiple adapters, I can, of course, use ID1 and ID2. So in my case, it's going to be chassis 1, server 1, and also adapter 1. So here I can do some show commands. So the CLI is not very self-explanatory. It's a different CLI than you're used to. But let's go back. Here we say attach the MCP. The MCP is a special boot policy or a special why didn't it find it? Connect to the adapter. I'm connected to the adapter. Oh, and then connect, sorry. And then attach MCP. So we're in the MCP now, and now we can say iSCSI. I can do a ping first. Can I ping? Yes, I can ping successfully from the server towards the MDS switch. So this is my first step. Can I ping? And now I can say iSCSI get config. And it looks okay. I assigned an IQN, I assigned an IP address. I say I'm ready, and it reports no errors. I connect to a certain LUN with a certain IP address. It looks okay here. So what did it fail? It failed that there is no OS installed on the disk. So I can see now that I have no errors here. So if there would be a connectivity error, I would see that. Or I can do iSCSI show IBFT. Now I exactly read from my iSCSI server. I can read exactly what kind of disks do I get. And this is only this one. So I can do a lot of fun stuff here. So let's check how it looks here. What do I see now? I see that PWWN that I configured from my initiator is now active because it has the star. And as I just told you, the PWWN zoning works exactly the same as the IQN name zoning because they will get the same FCID. It's the same host on the fiber channel network. And now we can see it also matches with the zoning on the operating system disk, so on the disk itself. And a good command to troubleshoot your iSCSI is show iSCSI, first of all, initiator. If I see an initiator here, it is an active initiator. If it's not active, I need to specify the configured statement here. But this is an active one, because how do I see that? I see an FCID. I only see an FCID for a host which is active on the network. Second, show iSCSI virtual target. I only see a virtual target here when there is a device logged into this. So it means that there is some device currently logged into this virtual target. How do I see that initiator to target mapping? That is going to be the show iSCSI session command. And that iSCSI session will show that initiator blade number 1 with this IP address is currently in this session accessing this boot target. And it is active. And here are some other details, some data packets going back and forth. So here you can exactly see local and peer IP address. So very good troubleshooting command, show iSCSI session, how much packets were sent and received. And so this is how I can troubleshoot that. So everything works, it's just that my operating system is not properly configured. Let's reboot the blade to show you what happens. So I just Control-Alt-Delete this. So we can see exactly what's happening during the booting of the server. So you can see exactly how that driver is starting to initiate its connectivity. But that CLI configuration is very, very useful because all the error messages will show up there. So we'll just wait for the hardware processing and then we'll start booting the blade and we should see something. All right, booting the blade. Now I did not disable quiet boot, so we see a beautiful Cisco logo here that we can stare at for 20 seconds. And it hides all kinds of interesting diagnostic information for us. So again, quiet boot, setting that to disable to see more diagnostic information. All right. And now you don't see anything, right? So the fiber channel boot driver does show you some interesting statistics. So it will show you exactly what it's doing. But the iSCSI boot driver doesn't show you anything. So you just have to trust that it's working. So that's where we need that CLI configuration, as you can see back here. Go into my adapter configuration. Oh, it's already gone. Connect MCP, because I rebooted the blade. It's not connect MCP, it was attach MCP. And then say iSCSI get config. And we see again, no errors. We successfully logged in with a 10 millisecond latency. So now I want to go back and let you see what exactly is going on here. So what do we have now? We have this setup. We have a blade, we have a fabric interconnect, a switch, and an MDS. For this, believe me, this works. So again, the last part here, the VNIC, it's sending untagged frames in the VLAN. The fabric interconnect will place a tag on it. So that is my end-to-end Ethernet connectivity. So is that clear? The purple path for VLAN 100 is from end to end. We go from the blade, from that iSCSI VNIC, and then we go into fabric interconnect A. There the traffic is tagged, send out to switch 2, tag is removed again and send out to the MDS. So that is my Ethernet path. That is clear. What is important are these steps. So we have blade number 1. Blade number 1 has a NIC, a Palo card, and we have our MDS. Let me draw it in the middle. We have our MDS switch, and we have our disk. Let's work with the actual values. So this is our NIC, and you saw me configure a special the VNIC, and I called it iSCSI. Maybe a more differentiating name was a better decision. But iSCSI VNIC. That iSCSI VNIC there has access to the VLAN. Nothing else. Then in order to do, so in that VLAN, I could have done and install an OS on the local disk, run the OS, run the software iSCSI initiator inside the OS, and run iSCSI on top of it. But let's forget that for now. On top of my network interface, to support iSCSI boot, the UCS uses a thing called overlay VNICs. And the only application for using overlay VNICs is iSCSI. So I create an additional VNIC, which is called an iSCSI VNIC. And I called that iSCSI VNIC, I called that iSCSI boot. The iSCSI boot VNIC determines which VNIC am I using as a source. So that is this guy, that actual PCI bus NIC. What VLAN do I send traffic in? So if I would run iSCSI boot across my normal data VNICs, I could set VLAN tagging here, and I could even give it a MAC address. But that's the first thing that I configure. So I create an overlay VNIC called iSCSI boot, and other than these two settings, this iSCSI boot VNIC will get the IP address assigned, and that iSCSI VNIC, that is the MCP stuff that I'm reading now. That attached MCP, that is the iSCSI VNIC that I connect to. So going back to my CLI, this is the iSCSI VNIC that I read from. The configuration that I show here is read from the iSCSI VNIC. So this has a connection to the MDS. In my example, the iSCSI VNIC has an IP address of 198.18.100.59. That was assigned by the pool. So boot order, let me see that. 198.18.100.59. That is my IP address seen on the server. So this is my blade. That server, I told the server to set up a connection to the .10, and the .10 is configured here. So here my 198.18.100.10 is configured. That is my IP end-to-end connectivity. Now, where do the IQNs come into play? As I said, just like with Fiber Channel, we need to identify ourselves. So Fiber Channel and iSCSI need to identify who they are on the network with a certain identifier. The IQN is the identifier used by iSCSI. So both the server and the disk have an IQN. So in this case, this is IQN 2013 1130 blade 1. This is the IQN of the server that is allocated through a pool, as you see here. So here my IQN is allocated through a pool, and therefore this iSCSI NIC, or this configuration, this server, has this IP address and this IQN. And that's how it's going to connect to the iSCSI network. I'm going to make some room here. So IQN and IP are clear here. On the fiber channel side of things, I have a connection to a disk. That disk has a certain worldwide port name. It ends with 4C in our example. I'm not going to write down the whole IQN or the whole WWPN, but believe me, the one that we are using, show FCNS, is this one. So it says 4C here. That is my WWPN. Let's call them by the last octet. So WWPN, let's use a different color for that, 4C. That disk is advertised on towards the MDS, and here I tell the MDS IQN this blade 1. So here I say, all right, so IQN blade 1 has access to WWN 4C. That is what I want to do, right? I want to say, all right, this is the connection that I'm going to make. I'm going to say blade 1 connects to disk that ends with 4C. But these two guys cannot talk to each other because the iSCSI packet is not understood by the fiber channel disk. The fiber channel disk expects fiber channel packets, the iSCSI server expects iSCSI packets. So we have to have some kind of a translator in between, and that is our MDS. That MDS is going to say, all right, disk 4C, I'm going to hide that fiber channel part of it, and I'm going to say, all right, disk 4C here, I'm going to advertise that to the iSCSI network as boot disk 1. So boot disk 1 is configured as virtual target configuration on the MDS. So I'm going to say, all right, people, blade 1, if you want to connect to disk 4C, WWPN 4C, you need to connect to IQN boot disk 1, because that's something you understand, right? This connection in between here only understands IQNs. First of all, we set up the TCP session. No, we did that, but now we only can understand each other based on IQNs. So this boot disk 1 IQN is then advertised out of the MDS. The server is going to try to access that through its connection. Is that clear? Is that so? What I do is I configure show iSCSI virtual target. I say this port worldwide name is now going to be advertised as this IQN towards the iSCSI network. So it only applies to this piece of my puzzle. So only to the left side of my puzzle. And I run all kinds of access control features here. That is what I showed you as well. So I said only allow this interface, only allow this IQN to log into me. I'm not allowing anybody else. So this is what they call iSCSI access control. All done on the left side in this. So the real disk or the fiber channel network have nothing to do with this configuration. That's my first step. The next step is that I say, all right, this guy, number blade 1, the fiber channel disk is only going to understand fiber channel frames. So I need to do something to translate your iSCSI packet to a fiber channel frame. What do I need? I need a worldwide port name. So I'm going to say, hey, you guy, blade 1, I will assign worldwide port name. Let's check what it uses, 02. you will get worldwide port name 02 as soon as you go, if you want to go onto the fiber channel network. Then the MDS, so it will say here, all right, so blade number 1, I will assign you with worldwide port name 02. Now that 02 and 4C, they can talk to each other, right? That's just fiber channel communication. And this guy, blade 1 and boot disk 1, can also talk to each other. So now we have the right side of the configuration, the fiber channel side of configuration. We assigned, I said this initiator, so show iSCSI initiator. This initiator, this guy, exactly this guy, this is the manual configuration I did, translates to these worldwide port names. So virtual worldwide port name. This worldwide port name is now a host on the fiber channel network. If I do a show FCNS database, my name server database, along with all the real entries that I have, come on, oh shit. Along with the real entries that I have, like all these disks, I have a special one. And that is this guy. And it already says this is a iSCSI something. So here I say now this initiator, this iSCSI initiator is now a real fiber channel host. As here. So this will generate a virtual iSCSI host that's going to connect to the network. It's going to log into the network just like any other host. It's not going to do a floggy, if I remember correctly. No, oh yeah, it does. So it even does a floggy. It will register to the fiber channel name server, so the MDS will spoof a new host on the network. That's what it's doing. So exactly as you would expect to see a new fiber channel host on the network. And then because I have that 02 host here, and I have that 4C disk here, what remains is, so here I have something to do with called iSCSI access control list, so ACLs, as you can call them. And here on the fiber channel side, I have my fiber channel zoning that I need to take care of. So the last part here is zone these two together. Like I did here. Worldwide port name 02 and 04 and 4C are now zoned together and they can communicate. And that FCID, that 970200, matches exactly here in the zone. So this is what I need to establish my end-to-end connectivity from blade to disk on an iSCSI environment. And then as an additional feature, Cisco came up with that I can also zone actual IQNs in a certain zone.